we should be live. Welcome everybody to another live stream repair. We've got 4 HomePods that have showed up today for repairs. Let's see here, so let's go ahead and update the text on the screen there. Alright, so first up we've got Vincent's with no base. So we'll start off with a fairly interesting one. Then we're going to move on to Forrest's. Theirs has death farts. And then we've got Jeff. Welcome, Jeff. Theirs is a bit of a mystery. The eBay seller said that it had issues powering on, but we'll see what's actually going on with it. And then we've got Jim's, and theirs is going to need a logic board replaced. So that one's a special case, but we're going to get that logic board replaced there. Not something we normally do, since obviously good working logic boards are pretty hard to come by. But this is, like I said, a special case, so they're going to get a good logic board. So let's go ahead and open up Vincent's first here. Putting up a fight, yeah? Okay. Almost in. Very nice. Okay. Let's go ahead and get started, yeah? Starting to get too big for me to hold this thing. Okay. The first thing we want to do here is double check our symptoms. So Vincent's with no base, we expect it to power on, which it is. But once it powers on and we prompt the Siri voice complaining about the internet connection, it'll probably sound rather tinny, or like it's got a real lack of bass. So let's wait for that to boot up here. It's pretty obvious when your bass isn't working. There usually isn't any sort of in between. It either is working or it isn't.
I'm having trouble connecting to the internet.
Ah. That's actually good. So right now their bass is actually working. Let's go ahead and take this apart. We're going to inspect the subwoofer, make sure that it isn't on its way out. And if that all looks good, we're going to proceed, well, regardless actually, we're going to proceed further down and get that amplifier out. And then we'll inspect that. Give it a quick test and see if it's got DC offset here. Visual inspection, make sure nothing's, obviously damaged. So let's crack this one open. We're gonna first, before we forget, I do it, but I often either forget to mention that I'm doing it, but let's go ahead and strap ourselves in here so we don't zap anything. All right. Now we shall begin. Easy peasy. Got that layer off. I need to go grab my electric screwdriver. Yes. Let's get those T6 screws out of the display so we can pry that out. Let's make sure that our camera stays focused on what we care about here. All right, not bad, not bad. I gotta stick this down over here. That all came up, but that's good. It's easy to stick back down there. Nice. Let's get this mid frame out. Run away. Okay. Slide that mesh down a little bit. Yeet that mid frame. Get that logic board out. Let's unstick that ribbon cable. Snap, crackle, pop like my body. Expose those screws. I think I might close my door. Okay, so now we pry. Just jimmer. Yeah. Come on. Very nice. Okay. Yes. Okay, I had to close the door. There's just too much background noise out there. All right. Our first look into maybe what's going on here. Let's check the condition of our subwoofer. First thing we do is look into the window there. That gives us a look at the voice coil. And it looks nice and shiny, like a good, nice copper coil should look. It feels nice and smooth. No grittiness or sound to it. And it smells fantastic. So that subwoofer is likely just fine. Which means our issue most likely and solely lies on the amplifier. So let's continue our teardown here and get down to that. Let's get the power supply. Good evening, Robin. Yeah, let's get that power supply out. Disconnect the ribbon cable for the amp. As I always say, I woke up and we've got stuff to fix, so we couldn't be much better. I actually took next week off at my day job, and it was actually surprisingly easy to get the time off. It's also good timing because I'll take the time off work next week before everybody else takes off work and nobody's in the office during the actual holidays, right? Well, that's usually when it's real slow. So by the time I get back in, it should be pretty slow. And yeah, everybody else will be taking their time off around the holidays, but I can't stop working for too long, you know. So yeah, I'm just taking like a little week-long staycation next week. I'll be doing my day job, and I won't be doing any HomePod repairs or anything like that. I will still be accepting deliveries, so throughout the week I'll still be taking those in. I'll still be home, so if any show up, I'll be able to bring them inside. But I won't be doing any repairs till towards the end of next week. So yeah, just taking a little break. It's been a while since we haven't had a day or two where we haven't had a bunch of work to do, so. Okay, so let's do a quick visual inspection of the board here, see if there's anything obviously amiss. But it all looks okay. There's kind of like a little bit of dust or something near the bottom of the amp there. Right there. Voice. Ugh. I'm getting one in that dropped on a wooden floor since then it works, but it keeps rebooting every 3 minutes on the clock and starts with a big chirp sound. Ooh, that'll be some interesting physical damage to figure out. Alright, that's looking a lot cleaner. So what I want to do is get this board powered up and connected to our multimeter here so we can see if perhaps this bad boy has excess DC voltage going through as a result of those capacitors failing, aka the filtering capacitors, aka little shits, aka they don't do their job no more. AKA why they do this. Hey, not Scott, welcome to the chat. And you've got a great point. If you search on Google, Tech Insights Apple HomePod, let's go ahead and pull up our browser here. You will find that the HomePod actually cost Apple a significant amount of money to manufacture per unit. It was somewhere, yeah, So the total production cost per HomePod was $248. And then when they first launched, they were selling them for $349 a pop. So $248 per HomePod for Apple to manufacture them, and then they were only making like what, $100 at most per HomePod. That's insane. My bet was that they were banking on people getting sucked more into the Apple subscription ecosystem and paying for music services and what have you. So let's go ahead and power this on. We're gonna connect our multimeter to the subwoofer here and check out whether we've got DC offset or not. All right. So no actual problems with DC offset. We're sitting at 0 millivolts there. Let's see if I can give you guys an angle where you can see that screen. Dang lights. There we go. Let me double check my email in case I'm just misremembering Vincent's symptoms here. Let's see. HomePod was not used much and was working perfectly. Then one day bass did not work. Sound was still present but no bass. Sometimes when I turn it on, bass is present, but after a few minutes, bass disappear. Okay. So I think what we'll do is we will just leave this just like this on the bench. We're going to leave it powered on and everything. And we're just going to scoot that over to the side. And we're going to go ahead and start tearing down the next HomePod. And in a few minutes we will check again on this one and see if it's still bassy or not. Since it seems like it takes a bit of time for the bass to stop working on theirs. So that brings us to, for now, number 2, Forrests with no power. Oh, and you know what? We should probably play something on here while we're waiting just so we can hear if it dies or not. What do we torture ourselves with? What do we say? Scared the shit out of me. Alright, so we'll just leave that going in the background. Keep an eye on this. And in the meantime, let's get our text status here. All right, so encloses an original HomePod exhibiting a loud burp series after a bit of warm-up. Very good, very good. Okay. Okay. Yeah. Oh, my power cable. We're using it. Let's see, I've got another one floating around here. All right. So let's go ahead and power that up. And we're going to listen for how loud of a pop this gives us after it boots up, which isn't a surefire guarantee sign or way of telling, but it can be a good way of telling how much DC offset you have. And that is because there's sometimes is a bit of a delay in those filters removing that DC voltage whenever the amp turns on or off as part of its low power standby mode. So it's hard to tell the difference between a temporary sudden spike versus a constant DC offset that doesn't go away. You can't really hear the difference between the two. They're both going to make a popping sound. So let's go ahead and see what this one does for us. Oh boy, yeah, that's a fairly loud pop. And again, when we unplug it from power. So let's go ahead and get this torn apart. And we're basically going to do the same thing we are doing right now with Vincent's HomePod here, where we're going to get it powered up on the bench here, take our DC offset measurement and confirm that those filtering capacitors are going bad, and then we'll get them replaced along with a few other pieces. Okay. Oh, I think it just did it. I think the bass just cut out for a sec there. Yeah, there it goes again. All right, well let's put Forrest back to the side for now then, and focus back on Vincent's here since it seems to be doing its interesting. I want to get this flipped around without zapping myself. Don't do this. Okay. And then what I'm curious about is if something's overheating. So we've got a few things that are warming up on here. Interesting. Not quite sure what to make of this behavior yet. I'm almost wondering if something is overheating. What if we pause it? Does it still go away? It does. Whoa. Oh boy. I'm just dousing them, putting a little bit of flux on the board here and there around all the hot spots that I see on the camera. Maybe we'll find something here. This is very strange behavior. Haven't seen this before. Okay, so actually, I do remember seeing this behavior before. I think I've seen this exact kind of behavior occur when I see when I purposefully overheat the DAC right here. So I'm wondering if maybe we should try swapping out another DAC. But I'm not sure if I have any good ones. Let me look here. Okay, so this one looks like it's got a pretty decent looking DAC on here. Let's go ahead and pull that off. Okay. Replacement DAC has been harvested. Let's go ahead and try to swap that. Okay, I think we got that on there. Okay, let's put this back together and we will see if that made any change in our behavior. That's assuming we got the DAC, the replacement DAC on there properly. There is a chance that we didn't, but we will find out. There's also a chance that that DAC that I pulled from my parts board is also bad, but we shall see. Ooh, gurgle, gurgle. Alright, so we still have our base. That's good. Let's go ahead and find our HomePod here. There we go. And let's continue playing some test tunes. If it starts acting up again, it should do it relatively soon if we didn't. Yeah, there we go. Okay, so it wasn't the DAC. Huh. I think what we're going to go ahead and do is put this board to this side. I'm going to go ahead and swap them out with another amplifier that I've got. We can go ahead and make sure it's all ready to go, and we'll put their HomePod back together with a known working amp. And we'll spend some time later on this one. Okay. Bass drops. Nice. No pun intended. Okay, and here's the amp that we're going to use as their replacement. Obviously, I've got a whole bunch of speakers on it already, so we're going to go ahead and take all those off. Actually, before we do that, let's go ahead and double check and make sure that this board works and that it doesn't have any DC offset. So I'm going to put this DAC into my pile of parts here, since we know that's still good. All right. All right, do we have any DC offset?
I'm having trouble connecting to the internet.
Nope. No offset to be concerned with. This board is in perfect working order. Let me double check and see if it still has the original Schottky barrier diode on there. We're going to go ahead and replace that before we put this HomePod back together. But otherwise, this amp has a clean bill of health, so it is a perfect candidate to be reused. Okay, as I said, we're going to go ahead and replace the Schottky barrier diode on here since it is the original one. We don't want to send this freshly repaired HomePod back to Vincent here with the original diode causing power issues a few months down the road, do we? Get out of here. Alright. For those curious, the diode has a date code of 1746K on it. So it is within that range of diodes that we suspect are part of bad batch. Alright, fresh spanking new diode. This HomePod is ready to be reassembled because we already know it doesn't have any DC offset issues, so I need to retest for that. Let's see if we got that all ready to go. We are going to factory reset this and connect it to our home after the stream and do some extended sound testing just to make sure it's all good to go. With a whole new amp, it should be far from a problem for them ever again here, or at least anytime soon. But we just want to make sure that there's no issues with the replacement amp.
I'm having trouble connecting to the...
That's all good. And volume buttons light up nice and even. So Vincent's pod is ready to go. Let's set that to the side. And bring back Forrest's HomePod here. So while we were working on Vincent's pod, we started looking at Forrest's, and we confirmed that there was a rather loud popping sound coming from it, which is sometimes the sign that those caps are going bad and you've got death farts. So we've already confirmed their symptoms. Let's go ahead and tear it apart and get the amplifier on the bench here powered up and confirm our suspicion with those filtering capacitors going bad and allowing too much DC through. Nice. That one's a little bent. Interesting. It's time. Very nice. It's time for the woofer check. Give me that. Ooh. I just got a sneak peek at the board down there. I see some surprises. But first, our subwoofer. Let's go ahead and double check. The voice coil down there looks nice and healthy. It feels nice and smooth, no grittiness. And it smells fantastic. So that subwoofer is nice and happy still. Good to be reused. Let's get this amp out, because I see some damage on there already. If you've watched enough of our Death Fart repairs, you can probably see what I'm seeing here as well already, without going any further. But if you haven't, well, you'll see in just a minute. Do you see it yet? Okay. Here's the amp. And if we get nice and close there, right next to the subwoofer connector, we've got our classic 10 ohm resistor here that's blown up and is falling apart. This part here seems to most often fall victim to those filtering capacitors going bad, and again allowing too much DC voltage through, which causes the death farts, roasts your subwoofer, all sorts of havoc. So this is obviously going to need to be replaced. This is a 10 ohm resistor. I've got the exact part number up on my website under the common issues section if you want to know yourself. These are the filtering capacitors that typically go bad and allow that DC voltage through. So before we do any repairs on this board, I'm just going to go ahead and power it up and confirm our suspicion here, which is those filtering caps going bad and allowing too much DC voltage through. We'll be able to confirm that's the case with our multimeter connected to the subwoofer and the subwoofer connected to our amp here. So let's put some test parts on. Alright, what's it got? Oh, ho, 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 buddy. Almost, yep, 800 millivolts now, and it is rapidly growing. We'll go ahead and reproduce a death fart for you guys here on stream. One thing you can do to accelerate reproducing this death fart behavior is heating up those capacitors that go bad, which makes them even worse at filtering this unwanted DC voltage. And when this passes 2 to 3 volts DC, that's when those death farts are triggered and the HomePod restarts. So all we got to do is take our heat, just warm that up under there. We're already at 2 volts, 2.1 volts, 2.5. 3 volts. We're going to go ahead and set our meter to max mode so it only tells us the max reading. That way we can see exactly what it takes for this thing to fart on us. Wow. Not quite the death farts we're used to, but unwanted behavior nonetheless. Alright, let's go ahead and replace those filtering capacitors that's allowing that excess DC voltage through. Then we're going to replace that roasty looking resistor, since it's obviously damaged and it needs to be replaced. And then for good measure, we're going to replace the Schottky barrier diode on this amplifier. Not because it needs it, but because we want to. We do this for every HomePod repair. We replace that diode since it fails so often and causes those no power issues. For those curious, the diode has a date code of 1736K, so it's outside of the range of our usual suspect of bad diodes here. But again, we replace it every time, so we're going to do that last here. But first, let's take care of the source of all of our problems here, and that is our filtering capacitors. So sometimes one of these, if not multiple of these 4 big caps here, go bad and allow that DC voltage through the amp, which gets amplified, of course, because it's an amp, and then that signal gets sent to your subwoofer. Wreaks all sorts of damage and havoc. Put your amp under more load than it needs to be, put your speaker under more load than it needs to be. If you want to know more about DC offset, I suggest you do a quick Google search, because there's a lot of interesting information out there. But basically all you really need to know is DC voltage in your analog speaker is bad. Impacts the performance and longevity of your parts. Makes them work harder than they need to. Okay, old caps are off. We're going to put some flux on those pads and then grab our soldering iron. Put a little bit of low melt solder on the tip, and we're going to put that low melt solder on our pads on the board here. Easy peasy. We're going to put a little more flux on there to help hold our new filtering capacitors down. All right. Beautiful. Every time. Works like a charm. And those joints on there look fantastic. They are nice and square on there. Actually, that one on the end there looks a little too far up. Much better. Okay, with that out of the way, let's move our attention to that resistor there. Looking mighty toasty. Let's flux it up. And then we're going to grab our makeshift heat shield here. This is a piece of aluminum backplate from an iPad mini display that we cut up and then bent to shape. It's a little thicker than aluminum foil, obviously, so should help protect these plastic parts, that plastic connector right in here, and this big tall electrolytic capacitor right next door. So let's get that dead resistor pulled off now. There we go. It came apart as we pulled it off the board there, but we got it all off. We'll put those in the graveyard. Grab a brand new resistor. Fresh solder on the board and our new diode. We'll go ahead and pop that on, reflow it into place. And there we go. Alright, last but not least, let's take care of our diode there. Easy peasy. Let's cool this board off real fast and then we will give it a test. We'll see if we've gotten rid of that excess DC voltage and that it still sounds nice and good, and then we'll put this pod back together. Alright, what have we got? Okay. We've still got our sound. Our DC offset is hanging out at around 3 millivolts. 2 millivolts, even better. So, as long as our final DC offset measurement here is below 50 millivolts, that is within spec and safe to use and good to go, and you won't see those death farts. And this is a significant improvement from the, what was it, 800 millivolts that it started on a cold boot before it continued growing. So, this pod should be free of all flatulence. Let's get it thrown back together. Thank you very much. It'll find the hole eventually. before we put the final piece back onto this pod. If you guys want to see us do a video with these Budweiser Bluetooth speakers, leave a like on the video here. If we get one like, I will make a video on those speakers. We'll take them apart, we'll test them out, and we'll have some fun. Martin, I saw your name pop up in the chat and I immediately got to turn off the multimeter. Oh boy, but these aren't the only fun little projects I've been having come in recently. I've got another little surprise for you guys showing up in the next few days that we'll do a special video on. Got a lot of fun stuff coming up, so definitely subscribe and share the channel around with your friends, with anybody that's interested in this kind of electronics repair content and mucking around with speakers. But let's go ahead and see if we've got Forrest's HomePod here. I'll put it back together correctly and working as expected. Okay.
I'm having trouble connecting to the internet.
Aren't we all?
I'm having
Volume buttons line up nice and even. So same thing as, I think it was Vincent. Yeah, same thing as Vincent's pod. We're going to factory reset this after the stream. Pair it up with our home system here. And test it overnight to make sure that it still doesn't have any death bar issues. But in the meantime, that brings us on to our third repair for today from Jeff. And the eBay description said that this didn't power on. However, the eBay description also had a photo of a HomePod that was powering on. However, the listing was for multiple HomePods. They had multiple quantities. So I'm not really sure what we've got here, but we're going to go ahead and take a guess here that the eBay seller is being honest and they are in fact selling HomePods that aren't powering on. So let's get their box opened up and find out what the heck. What do we got? Also, the good thing is the seller looked like they accept returns. So if they ended up selling us something that wasn't as described, i.e. no power, then we can return this for a full refund without even taking it apart. All we want to see here is an issue that we can repair at the end of the day. If we can fix this for Jeff, then we'll all be happy. But if we were sold a bricked HomePod, then I won't be happy. Alright, here it is. It is wonderfully packed, if I may say. The seller, honestly, this is probably one of the best packed eBay HomePods that I've seen. They had the box completely surrounded and firmly packed with bubble wrap, and it did not allow the box to open up in transit, which is a common thing that happens, and that it allows the power cable to wrap up around the side of the pod and cause a little bit of minor cosmetic damage. Alright, so I presume this is the eBay invoice. 4 parts only, not working, might have some cosmetic changes. So that's not what I want to see highlighted on that here when the description said won't power on. But I have my hopes. I don't hear anything rattling around. It's honestly, it's in pretty good shape too. Alright, fingers crossed. What did they sell us? Yes! It won't power on. So that means we can likely fix this for Jeff here. And we're getting about 4 to 5 watts of power draw from the wall. So that's pretty typical for that Schottky barrier diode on the amplifier shorting out and causing this no power behavior here. So let's get this torn apart, confirm that that diode has shorted out, and get it repaired. I was really nervous when Jeff shot me an email with the screenshot of the eBay pod that he purchased, because I found it on eBay and the description said won't power on, but they were definitely using photos from another HomePod that did power on. And why that makes me worry is typically when I see eBay sellers sell these things advertised as won't power on, a lot of times, either deliberately or not, they misconstrue that as unable to connect, or sorry, actually what I meant to say was when they've got pods that boot loop or have the blinking volume buttons or some other software issue, they misconstrue that, willingly or not, as won't power on. So we want to try to avoid those without repairable issues like those. But these ones with no power and various sound issues, those are almost always repairable. I know Jeff was watching earlier. Are you still with us, bud? Oh, that came apart wonderfully. Minimal amount of adhesive lift. Let's just stick that little bit back down there. Get the mid frame out. Hey, Jeff, I gotta ask, man, is your last name actually Miracle, or is that just like an online name that you use? Hey, Jim. Glad you're here with us, too. We got a party. time for the pry. Very nice. Very, very nice. That's your real last name? Man. That's cool. Almost got it. All right. Nice. We proceed. Oh. Yeah, get him. Get him. Yeah. Oh man, if I was taking these out by hand right now, I'd have to take Rick. I like that, George Zer. Alright, we are inspecting the subwoofer for any damage. Voice coil looks good. Moves nice and smooth. And it smells fresh. Smells like a happy little subwoofer. Always sniff those subs. While a bad one may or may not pass the sniff test, a good one always will. Okay. Here we are. Do a quick visual inspection of our board here. We've got a date code on our diode of 1748K, so I think we all know what to expect when we go and test that diode. As far as the rest of the board, it looks really good. So let's get up close. There's your diode right there, 1748K. Let's go ahead and grab our multimeter. Confirm our diode is shorting out here. Yes, it is. It's dead. So let's get it replaced. Alright, we're just going to leave that sloppily placed on there so we can observe the magic of the flow of solder, do the hard work lining that up there for us. Check out these cool moves. Look at that. Like magic. We'll give it a few little taparoos. Make sure it's perfectly centered on there, or at least as centered as the pads want it to be. And there you go. Looking fresh. So, let's cool this board off here for just a minute in front of the fan, and we will give this board a test. That'll do. Is it best to leave it plugged in for a long period of time? I believe so. I am of the camp of thinking that use the thing the way that Apple designed you to use it. And that is to just leave it plugged in 24/7. Not to worry about unplugging it whenever you're not using it, but just leave it plugged in all the time and use it as much as you want at the loudest volume that you want to use it at. If they didn't want you doing something like cranking it up to a specific volume, they wouldn't let you turn it up to a specific volume. If they didn't want you leaving it plugged in all the time, I'm certain, almost completely certain, that they would have something on their website somewhere saying that you shouldn't leave it plugged in. But you should probably just leave it plugged in all the time. I do suggest you put it on a surge protector. Not a cheapo Dollar Tree power strip, but specifically a surge protector. You should be doing that for any of your electronics that you really care about. Like if you were to lose everything in your house not connected to a surge protector, just keep that in mind, because that's what they do. They protect your house or your electronics from power surges. So put anything that you don't want to have to replace in the event your house has a power surge onto a surge protector. Especially HomePods, considering how how much they are. So let's get our multimeter powered on here. Let's plug it into power. And there you go. We'll let this boot up, and then we will confirm that there aren't any DC offset issues sneaking up on this amp as well. All right. Oh boy. So we've got 450 millivolts of offset, and it's continuing to grow. So that's no bueno. We don't want to see this more than 50 millivolts. And we've got a pretty healthy popping sound with a bit of speaker movement there as we unplug it from power. So those filtering capacitors need to be replaced. Let's go ahead and do that real quick. Here we go, back up close. There's our guys. Those big 4 brown caps right there. We're going to go ahead and replace those, and that should get rid of that excess DC voltage that we saw on our multimeter there. Oh yeah, it's totally fine for the HomePod to go to sleep. It's still powered on. It's just sipping power. It goes into a low power mode. But my advice, unless advised otherwise by Apple directly, is use it the way it was designed, which is to leave it plugged in all the time. I heard a package has been delivered. Whose is it? Is it mine? I'm gonna go check. I'm gonna go see who's it package. It was not for me. It was for the wife. Alright, let's prep this board for some new filters. We're going to stick some low melt solder on those pads there. And here we go. Baba booey! Amazing. Oh, beautiful. Oh, boy. Look at that. Ah, you just cannot get better than that. Alright. Let's cool this board off again. We will give it one final check, and then we will put this pod back together. We use the low melt solder on those filtering capacitors in particular because we want to minimize the amount of heat that we're pumping into those brand new capacitors. My idea behind that is the less heat that we have to subject those to, the longer they're going to last. It's an inherent property of these types of capacitors to lose their effectiveness over time. How long that takes is a matter of how much they're used, under what kind of load, and the way that they were installed, of course, as well. So that's my idea behind using the low melt solder for those caps in particular. The rest of the parts on the board, I don't really care too much to use the low melt stuff on, with the exception of the amp chip. Since that is already difficult enough to replace, we make it a little easier on ourselves with the low melt. But the normal solder that we use on this, on the rest of the repairs, that stuff can, especially in this area on the board, the board really loves to soak up a lot of heat, so you can end up really putting those new caps through some torture if you're using normal stuff. I'm sure it's fine. I mean, for a while we were using regular solder to put those new ones on, and we weren't too concerned with the heat, but it's just a kind of little precautionary thing that I started doing. So this stuff is actually supposed to be used, I believe, for soldering. I believe this stuff was designed for SMD, or I can't remember. It was used for some sort of specific type of chip for reflowing, and you are able to use this stuff for install, but yeah, the that area of the board, and for that matter, none of the parts on the inside of a HomePod ever get anywhere near the actual melting point of this solder. So no worries there either. Alright, what do we got? Oh, cool. The low melt I have is melting on a way to low melt to lower the melting point with your existing solder. Yeah. And honestly, I'm sure that most low melt solders and most solders in general are going to, work if what you do with it. Where was I going with that? This is why I don't talk and work at the same time. I end up rambling and not remembering where I'm going. It's that ADHD brain cursing us. What was I gonna say? Something about low melt solder. I don't know. At the end of the day, use what works best for you. I do see the low melt stuff used more often for what you're talking about. That's probably what it was made for, and like you said, not made for actually repairing things like this. But it works too good for that. So we're still sitting here at around 5 millivolts of offset. Our base still works just fine. So this board is all ready to go. Yeah, because in my mind, I'm trying to think of what reasons would you have to not use low melt solder for some of your repairs. And the only reason that I could think of, and I'm not, I'm not like a freaking wizard like Lewis Rossman or Northridge Repair or any of those guys way up there. But the only thing I can think of as to why you wouldn't want to use low melt solder for installing components is if the heat was a concern and you had a chance of melting those joints with that low melt stuff. But I think this stuff doesn't melt until 191 degrees. So well above what the filtering capacitors should be running at. And it's really brittle. That makes sense. Yeah, you wouldn't want to use it on something like a connector where things are being plugged in and unplugged all the time and it's under a lot of physical stress. I definitely wouldn't be using low melt solder for something around that area. That said, to slightly contradict myself, when I replace the logic board connector on the amp, sometimes I'll go for the low melt solder mixed with the usual solder to make it a little easier for the solder to flow without putting the whole area under as much heat as it would take with the regular stuff. Yeah, I intentionally looked for some low melt stuff that had like I looked for something that was high enough that it wouldn't run the risk of melting under normal use, while still being low enough that I could easily and quickly replace those caps there. It's good stuff. It flows real easy, and it's got flux mixed into it as well. Doesn't stop me from gooping a bunch more flux on there, but how do you replace that connector? So what I used to do, is I would just hold the amplifier with one hand and then heat up the bottom of the board from underneath with the heat gun, and then eventually that will melt the solder on your connector, and you can pull the old one off if you're trying to replace an old one, or if you're trying to put the new one on there, you tin your pads, of course, and then I would hold the board, pop the new connector on there, and then reflow it from underneath. What I've got now are these guys, these little magic hands, or helping hands, and what I can do with these, instead of holding the board by myself. These can hold the board for me. And then I can hold the connector with my tweezers with one hand and then heat up the bottom of the board with my other hand in the heat gun. And you just keep heating up the bottom of the board until that all melts on there, and you're basically good to go. I like to take a fine tip on my iron after you reflow the connector on there and touch on every single one of the pins onto the board, just to make sure that it's got a nice solid connection on there. Oh boy, that came from nowhere. Get back in there. Ooh, Jeff, you're getting your hands on another one? Good, good. What is this screwdriver? This is the Miniware ES15. Great little screwdriver. My only complaint with it is I cannot for the life of me figure out how to magnetize the tip. I've tried various magnetizing tools. I've tried different tips from different manufacturers. The only thing left that I can think of is finding a small magnet to stuff in there to perhaps make it a little stronger. That's my only complaint. Aside from that, this thing is awesome. As you've obviously seen in our live stream repairs ever since we got this thing, we've been using it for quite a few of the steps of the process here. And it speeds things up a little bit, but more importantly, it saves our hands on that constant twisting motion and allows us to put a more consistent amount of force into these screws when tightening them. And yeah, it just really saves on the hands, especially with the tougher screws that are just really stuck in there. And it feels like every turn is just getting harder and harder. That little thing is a beast. It'll tackle almost any screw you encounter in a HomePod. It's not cheap. I'll tell you that much. It's not cheap. But the build quality of this screwdriver, it's definitely worth the money in my opinion. And it comes apart at every little bit of this comes off, and you can fix it up if anything happens to it. I'm sure their warranty is excellent too, and if you have anything that fails, you can just reach out to them and they'll send you the replacement part and you can just fix it yourself. That would be cool. let's see what we've got for Jeff. Plug it into power, smack it around a few times, and you got yourself some power. Ugh. All right, what do we got?
I'm having trouble connecting to the internet.
Aren't we all?
I'm having trouble.
And volume buttons light up nice and even. Oh, Robin, have a good nap, have a good sleep, a good slumber. Thank you for stopping by. And we got Jeff's pod fixed up without a problem here. Since this came from an eBay seller and then it's going to Jeff, we're going to go ahead and factory reset it for them before we ship it back. But aside from that, we're looking fantastic today so far. Which brings us to our last repair here for the day from Jim. Okay. Now, Jim's HomePod was here already a few weeks ago. Jim had bought this HomePod off eBay, described as, it was being sold as for parts or repair. When we got it, we were expecting blinking volume buttons issues. That's right. Jeff bought this knowing that it had blinking volume buttons, but we were going to end up using it for parts to fix another one of his pods, I think. And when we got it from the eBay seller, surprisingly, it worked just fine for us. So we went ahead and tore it all the way down, replaced the Schottky barrier diode on the amplifier, checked it for any DC offset, and then put it back together and shipped it back to Jeff. And when Jeff got it, it started having blinking volume buttons as soon as he powered it on. So we're gonna go ahead and break one of our. We're gonna go ahead and make an exception here. We don't normally offer logic board replacements. But considering Jeff's situation, or not Jeff, Jim's situation here, let's go ahead and update the text on our screen. Considering that, we're going to go ahead and replace, do a one-time logic board replacement for Jim here. In addition to that, Jim wanted us to go ahead and dye the mesh on this blue. So we're going to go ahead and take the mesh all the way off on this pod, and then take care of that this weekend. But in the meantime, we're going to go ahead and take this all the way apart and make sure that we can get this the hardware working again at least before we color this blue. So the first thing, as always, I want to go ahead and plug this in and double check that it is in fact misbehaving for us here. I'll be absolutely shocked if this boots up for us without a problem. It's taken an awful long time to boot up, so I'm pretty sure we know what to expect here. But we're going to follow through. Yep, there you go. So it's got the blinkies. Let's go ahead and start taking this apart. One thing I suppose we could try here real quick. I want to try a different display, because we have seen the display damage in the past cause no power or blinking volume buttons like this. It's very rare, but yeah, and I don't see any damage to the display either, so. Or the ribbon cable here. It all looks good. Let's try a different display. Just in case, just maybe. Just maybe. But I'm not hopeful. Yeah, it's gonna do the same thing. Okay. All right. Let's continue tearing this down. I think we're gonna go ahead and get that rubber base off so we can pull this mesh out. How do you cancel the spot focus on the Sony ZV-E10? Ah, nice. And with that removed, we can reveal our 3 T5 Torx screws holding the base of this mesh down. All right. All right, and that's as far as we have to go. Since we've already had this pod apart before, we've already done the usual preventative maintenance on this bad boy. Let's get that mesh pulled off completely. And we will set that to the side for this weekend when we will have a chance to color that dark blue for them. That is their request. In the meantime, I want to go ahead and connect a working logic board to this just to make sure that this is still functioning otherwise, and we'll be just about done for the day here. So we're just going to go ahead and connect their new logic board and their old display here. And if this boots up, then that's it. We'll be done for the day. Oh yeah, Robert, don't worry about it. We're going to dust everything off before we... Yeah, we're going to dust that all off. We've got a power duster. We get far worse in every once in a while, so this is nothing. But let's see if this boots up at least for us. Okay, so it booted up. Let's go ahead and factory reset it. We'll make sure that that works before we send it back to them. They're going to have to factory reset it anyways. This is a new logic board. Well, new.
Your HomePod is about to reset. Keep pressing until you hear 3 beeps.
Boop, 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 boop. Nice. And then we will just make sure that actually factory resets and shows us the setup. Because we factory reset Jim's before we sent it back, and that makes me salty. Your repair service is drying up the broken used market. No kidding, man. If it isn't me snapping them all up, it's everybody watching my videos that started snapping them up. All right. So that reset without a problem. It's given us the setup animation, played the setup tone without a problem. So we're going to go ahead and dye their mesh blue this weekend, and then you guys will see us put this back together when we get that finished up. And that's all that we had for you today. We got everything otherwise fixed up the way we wanted to. No surprises. So if you guys have any questions about any of the repairs that we've done here today, or HomePod repairs in general, feel free to leave a comment down below. I always suggest folks check out the website, nixfix.com, where I've got all the information for the repairs that we do here on the channel. If you go to the common issues section, we've got a breakdown on most of the issues that we fixed here. If you would rather mail your HomePod in for a repair here on the channel, I've also got my contact info up on my website.